Yes, hello everyone. So today we are discussing a question which is from Irido, and it's a very beautiful question, very nice question, because it helps you to understand the concept of vectors, and plus many students will be having problem in understanding angular velocity, angular acceleration. So this question is very important for understanding those concepts. Okay, so let's start with the question. I've already taken the privilege of drawing the diagram so that later on when we start solving the question it becomes easier, less time consuming. Okay, so let's look at the question first. A round cone with half angle alpha equal to 30 degree and the radius of the base r equal to 5 centimeter rolls uniformly and without slipping over a horizontal plane as shown in the figure. The cone apex is hinged at the point O, which is on the same level with with the point C, the cone base center. Okay, that's the point C. Okay. The velocity of the point C is V is equal to 10 centimeter per second. Find the moduli. Moduli means magnitude. Find the magnitude of the vector of the angular velocity of the cone and the angle it forms with the vertical. Also, they're interested in finding the vector of the angular acceleration of the cone. So, very important question and very nice question. So, based on the given data, I have drawn this diagram. You can see it shows that the angle that the cone makes, the half angle that the cone has is 30 degree, and this OC line, they are saying the O and the C are at the same height. Okay, they're at same level. So can I say that the OC line represents a horizontal line, right? And the point C is having a speed of 10 centimeter per second. This cone is actually undergoing a revolution. The cone is revolving around this vertical axis. And how it is revolving? The cone's end, the base, is actually rolling here. Okay, it's rolling, pure rolling. That means there is no slipping happening at this point. That is a condition here. Okay, so now they are first of all interested in finding the angular velocity vector. So the most important thing here to understand that there are two angular velocity vectors. Number one, because of the rotation of the cone is actually rotating about this axis OC. It's spinning, we can say. There is a spin for the cone about the axis OC, plus there is a revolution of the cone about this vertical axis. So because of the spinning, there will be one omega, and because of the vertical axis, the revolution around the vertical axis, there will be another omega. So I can say that because of this motion like this, we can say the omega of the end point of the cone, this region, it will be having an rotation in this manner, right? Because of this, it will have an omega outwards in this way. Can I call this as the omega S? The omega S representing the spin omega, right? Because of the rotation of the cone about its own axis, there is an omega. Plus, this same cone would be revolving around this circle that you see, the bigger circle, right? So it will be revolving around its vertical axis. And based on the revolution, we can understand that there will be one omega also acting on this. Okay, so let us say that omega is acting in downward direction. How I am getting this omega direction and all? We get that by using the right hand thumb rule. I hope that all of us are aware of how to find the omega direction. Look at this. Because of the rolling action of the cone, you can understand the cone is right now in this position as per the board, right? And now the cone is going to move out. So how would it move out? It will be rolling and moving out. So that same action I'm showing, rolling. So because of that rolling, you curl your finger in the direction of the rolling. Whichever direction your thumb points, that will be the direction of the angular velocity. Same manner, this cone is basically revolving, right? It will be revolving around this vertical axis. So the cone is going to move in this way. Curl your finger in that direction, and whichever direction the thumb points, if you're a C, thumb is pointing in downward direction. So whichever direction the thumb points, that represents the direction of the omega. And this is omega R, we can say. R representing revolution. So two omegas we are having. Now to find omega R, we will have to use the concept of 2 pi by t. We can use this. What is the meaning of 2 pi by t? 2 pi is the total total angle, the radians covered by in one circle by this cone, and in how much time it is doing. That is the time. Now it's very easy to find the t here. We can say that 2 pi divided by t is nothing but, we can say, it is the time period. The time period can be easily said as the total circumference of the circle is 2 pi r, and the circumference is covered by this cone. The point C is covering this circumference with what speed? It is covering this by the speed of this v, that is 10 centimeters per second, right? So from here I can cancel the 2 pi's and I'll be able to get the omega r equals to v by r. Now the important thing is, what is this r? The r here is this distance, and as per the question, how much is that r given? So they have not given this r, but we can find it, right? That r is not given. Let me call it as a small r, but they have given this angle. So using this angle, which is 30 degree, I'll be able to find out that r. I can show that here, that tan 30 degree is equals to opposite, that is capital R, by the adjacent small r. So small r is equals to r divided by tan 30 is 1 by root 3. That root 3 would be going up, and I'll get r is equals to capital R, which is 5 centimeter. So I can say 5 root 3. Okay, that is my r. I can substitute that here. So this will be becoming 10 centimeter per second divided by 5 root 3. So this will give me an answer as 2 by root 3 radians per second. Nice. Same way, I can find out the omega as in furthermore easier fashion, because it's like a rotation, right? For rotation, we can directly say it is v by r. And what is a v value? V value would be 10. And whatever we are having the radius at that end point, that radius is nothing but r. So this will be divided by 5. So that gives me an answer of 2 centimeter. Sorry, 2 radians per second. So very important concept. I have the spin angular velocity and I have the revolution angular velocity. Now look at the angle both of them are making. Spin velocity is in the horizontal direction, and the revolution angular velocity is in the vertical direction. So if you're interested in finding the resultant of both of them, then I can say the total omega is coming out to be under root of omega r square plus omega s square, which will come out to be under root of 4 by 3 plus 4. Right? So this will give me 12 plus 4, that is 16. 16 by 3 under root. So that will be 4 by root 3 radians per second. And this 4 by root 3 radians per second, what we are getting, we can keep it as it is, no need of solving it further. One more question that I'm checking there, they have asked in the same part, is the angle it forms with the vertical. See, I'm having two vectors, right? The omega r and the omega s. If I try to draw them as vector, so I can show it here. This is my omega r and this is my omega s. The resultant of that would be somewhere like this, omega. So what angle it is making with the vertical, if they ask, I can call it as, let us say, theta. And just by using the vector concept, I can say the tan theta here is equals to the opposite by the adjacent. So opposite is omega s by omega r. Omega s value, how much we got? 2. And omega r value we got 2 by root 3. So this will come out to be root 3. And from here we get the theta value equals to 60 degree. Right? So very important concept. The cone is having two angular velocity, omega s and omega r. The resultant would be that omega, resultant of these two vectors, that is a total angular velocity. Okay, now angular velocity we got, they want the angle. So using the concept of vector, we got that. Nice. Now second part, I guess they're asking angular acceleration, right? They're asking the vector of the angular acceleration of the cone. Okay, so we are interested in finding the vector angular acceleration and magnitude of that, obviously. So we don't want the vector as such, we basically need the magnitude. Now let us understand this. Is my omega r changing? Very important. Because this point C is having a constant speed of 10 centimeter per second, that speed is constant. If that speed is constant, then definitely it will be moving along with that same speed throughout with time. As the time changes, my speed will not change. And what about the direction also? It is rotating in the same manner. Let's say if I am looking from the top, as a viewer, I am looking from the top. This is where the observer is. This is the eye of the observer, and the observer is looking from the top bottom. Then what is the rotation that he sees? He'll be saying that he's seeing a clockwise direction rotation for that cone. So the center will also be rotating in the same way clockwise. If rotation remains same, the direction of omega remains same, the magnitude also remains same because the c is having constant speed. So conclusion, omega r is not changing neither in magnitude nor in direction. But what about omega s? The omega s is continuously changing. So please look at here for that. I'll draw here. From the top, when I look, this is the center of that rotational system, and I am finding that omega r is a vector going in. When I'm looking from the top, cross means actually going in. So when I look from the top, the omega r vector I'm finding going in, and at this moment I'm having the omega s vector in this direction. After some time, because of the rotation, the omega s would be becoming in this direction, and after some time it will become in this way, this way. So basically my omega s vector keeps on revolving. And what about the magnitude of omega s? Constant. But direction of omega x keep on changing. So whenever there's a change in direction, acceleration will definitely come, right? Velocity changes. Velocity is vector. It's not only scalar. So my omega s vector is changing, magnitude remaining constant. So let us find out the acceleration for that change in my omega s. So for this, we'll use a simple concept of vector, which we'll be using in multiple derivations eventually. So please make sure you understand that I am drawing my vector omega s in this way. This is the initial direction. After some small duration of time, this cone has rolled by some distance. Some amount of rolling has happened, and the cone has revolved by an angle of d theta, a very small d theta. It has revolved. So, what is the new omega that I'm having? That is also same omega s, magnitude wise, it is same. But what about the direction? The direction has changed. So these both vectors are having same magnitude, but direction has changed, and this can be said to be as the d omega, the change in omega that has happened, right? So see, what I can say is this is vector omega s's magnitude, correct? And this is a new vector because direction has changed. So I can say this is omega s dash vectors magnitude. Magnitude is exactly same, but they have become a different vector. So vector wise, if you want to say, you can say that omega s dash vector is nothing but omega s vector plus d omega vector. Just simple vector logic. Now I am interested in finding the alpha, right? So can I say from this vectors, first of all, can I say that this dw is looking like the arc of that? It's an arc length. Okay, actually it is perpendicular. Okay, but we can say that it is behaving like an arc because the d theta angle is very, very small. So this straight line can be considered as an arc. If that is the case, then can I say d omega is nothing but the length, which is omega s into d theta? Arc length formula I'm using. Now differentiate this. So I'll be getting d omega by dt is equals to omega s being a constant as it is, and then d theta by dt. Okay. Now, d omega by dt, isn't this what we need to find out? This will be called as the alpha, angular acceleration, right? The change in omega, d omega by dt, that is equals to omega s. The change in theta, who decides the change in theta? Is it the omega s, that angular velocity, or is it the omega r, the revolution angular velocity? So remember, spin doesn't decide the angle, how much the cone has revolved. Sorry, how much the cone has revolved will not be decided by the spin, it will be decided by the revolution angular velocity. So now I can write this one as omega r You should be understanding this part. Okay, it is very important. Omega s into omega r has become my alpha. Now see, I am not interested in finding the direction of alpha as per the question. They're only interested in the value of the alpha. So this is the alpha. Substitute the omega s, how much it is? 2. And substitute the omega r, which is how much? 2 by root 3. And we'll be getting it as 4 by root 3 radian per second square. Okay, this will be the answer. Somehow we are getting the same answer for both of that. Okay, now what if you are interested in the direction? That's the question. If you are interested in knowing the direction of alpha, then we can understand that in a pretty simple way. Okay, see, let me draw that diagram here. This is how, okay, this is the cross. This is about direction of the omega r, and this is the direction of the omega s at some moment. After some small duration of time, it became like this omega s dash, and this would be considered as the d omega, right? So this is omega s vector, this is omega dash s, and this is the d omega, the change. Now I want my alpha's direction. So this equation, from here you can understand one basic thing, that by doing the multiplication of two vectors, I am getting again a vector. This only happens by cross product. Alpha is equals to omega s cross omega r, or it would be alpha vector is equals to omega r cross omega s. Which one it is, we have to find out. Pretty easy to find out. Which direction is the d omega? See, this direction. Which direction is the omega r vector? Inwards. Which direction is omega s vector? This direction. So I have omega r and omega s direction. I have to cross it in such a way that my resultant should be coming in d omega direction. So if I do omega s cross omega r, omega s cross omega r using right hand thumb rule, I am curling my fingers from the direction of omega s to omega r. I am getting the thumb in the direction this way, which is not the direction of d omega, that is opposite to the direction of d omega. So that means omega s cross omega r is not correct. This will not give me my alpha vector. So my alpha vector should be this one, omega r cross omega s, omega r cross omega s. Yes, so this will be the formula for our alpha vector formula. Okay, anyway, in this question we don't need that vector, but still I'm saying this will be our alpha. Which direction the alpha vector is? Alpha vector is exactly in the same direction as d omega. Remember, this is a top view. Okay, in this diagram, if you ask me which direction is the d omega, then if you try to figure it out, then d omega would be in the same direction as the velocity, like this. Okay, so I hope you have understood. It's a very beautiful question for understanding the concept of the omega and the alpha. Spin omega, revolution omega, and alpha. Alpha is purely happening because of the spin. The revolution omega has no contribution in the alpha, because that is remaining constant both in terms of direction and magnitude. It is the omega s which is even though remaining constant in magnitude, but its direction is continuously changing, and because of that there has been an acceleration. Okay, I hope you have understood. We'll stop here.